Hello Algebra 1, glad to have you all back here for another video session, and today's material will be on your practice mid-unit. Yes, you heard me right, a practice mid-unit. I know it might, for some of you it might feel like we've been taking tests very often, but hopefully most of you are thinking yay, because this is an opportunity to continue to boost up your grade. I know that many of you heard that your grade cannot go lower than your March 13th grade, which was the last day we were in school together, but that doesn't mean that your grade can't go up, which would be wonderful. If you could do all this effort and learn and put yourself in a better position to succeed next year with geometry, then that would be great, and your grade can definitely go up. So kudos to all of you who have been continuing to put in a lot of effort to learn and to complete your assignments and to watch the videos and to redo your homeworks until you get 100% and redo your tests until you get 100%. So really, really good for you. Keep it up. As long as you're willing to learn, I am willing to teach. So here we are. And again, as I mentioned, your practice mid-unit is today, and your actual mid-unit will be open Friday for period 6, Monday for period 3. Now, I'd just like to remind you that if you haven't taken the end of unit 2, because this is mid-unit 3, right? We're in unit 3. If you never finished end of unit 2, please take some time to go back in ALEKS and complete those. If you've fallen behind with some of the homeworks, do those first. Do them in the order that they were assigned. I try to keep them numbered so you know which one's which. I think that will help you progress in a better way than to just be doing random homeworks here and there. So if you have any questions or you need any support, remember that I'm here for you. You can message me at any time. And today's video is going to be going through the practice mid-unit with you. So if you'd like to pause the video now and just go ahead and try the practice mid-unit on your own, go for it. Try them out. See how they go. Notice that I have unlimited attempts for homework 11, and Mrs. Martin will be taking the best score. So again, if I don't do as well as I thought the first time, I can just do the quick retake. I do the problems that I got wrong, and I get extra points. So that's always a plus. Okay, so same thing with the tests, by the way. If you didn't get the score that you wanted on the tests in ALEKS, go take it again. It allows you to take it again. It does the quick retake where you only take the ones you got wrong. Let's keep this learning process going, okay? Our goal is mastery. So if you don't get it the first time, it's not a big deal. You go back, you learn again, you get it the next time, okay? So let's go ahead and get started. So our practice mid-unit is going to be covering the 3 methods that we learned for systems of equations. So if you don't recall those, that's graphing, substitution, and elimination methods. Okay, so we've got 3 methods to solve systems. So let me annotate this one just so we can talk about it a bit. So if you remember, systems of equations, their solution is the point where 2 lines cross. Okay, that's my solution. And that point, if I plug it into both of those equations for those lines respectively, if I plug in that solution, that whatever the solution is, right, x, y, when I plug those in, it'll make both of these true. Okay, that's our goal. If one of them is false, then it is not a solution. For example, if I've got a point down here, this point is true for this line, but not for the flatter line because it's not on that line. Okay, so it's really important that we understand that. If you're a little bit confused, maybe go back to the older videos about graphing so we can kind of relearn how that all works. And this first problem, which I might add is going to be very, very similar to the actual mid-unit. This first problem is just asking which points are solutions. And really my job here is to plug in. Okay, I need to plug things in and see if they are true. So let's do that. I've got 8x minus 2y equals 6. And my job here is to substitute. So I'm going to have x and y, and I'm going to substitute using a different color here. Let's do x is purple, and y will be black. Okay, so I substitute everything in. Notice that nothing happens on this side. It's just a number 6. Nothing's going on over there. No letters, no substitution, no simplifying. It's just a 6. And I can go ahead and do work over here on the left side. 8 times negative 2. I'm going to be very careful with my negatives. Over here, negative 2 times negative 11. Make sure you remember the negative here. That's positive 22. Okay, and again, I'm just bringing down the 6. Nothing's happening over there. And then negative 16 plus 22 is actually 6. So that one was true. So true for the top equation. Now I can't click yes though until I prove that it's true for the second equation. So it's true for the first. Let's see if it's true for the second. I'm going to continue my work here. This time I've got y equals 4x minus 3. Again, I'm going to substitute here. Actually, I'll leave off the parentheses. I'm going to substitute y is black, so negative 11. And then 4 times x. And if I remember looking over at my paper, x is negative 2. Okay, so I can go ahead and do some work here. I've got negative 11 equals 4 times negative 2, that's negative 8, minus 3. Negative 11 equals negative 11, so that one's true. Yay, that was lucky. Okay, so we did some careful work substituting. We proved by substitution that both of these equations are true. So since they're both true, I can go ahead and say that yes, it is a solution to the system. Okay, so I'm going to go ahead and do that with the next 3. You can do those on your own because I don't want to waste your time doing the same type of problem over and over again. But again, if you need support, you can always come in and ask me questions. So I'm just going to go through these so we can continue on. Okay, so again here we have 3 systems of equations, and we're trying to determine what's the solution. Now, if you remember from our previous videos with systems, it is possible to have no solution or infinitely many solutions. So keep your eyes out for that. And if you're not sure what I mean by that, please go back into your notes or go back and watch the video and get a little bit more in-depth information about what it means to be no solution, which came from parallel lines, or infinitely many solutions when the lines were the same, they were equivalent. So if, again, you need some help, always go back in the old videos, everything is there. So for system A, again, in graphing, we are looking for the point where the lines cross. And in this case, we have one right there. Okay, and so once I see that point, I know that I've got one solution. And that one solution is the ordered pair that that point is located. And that's x is 3 and y is negative 2. Okay, looking at the next one, it looks like there's only one line. But if you notice in their writing here, they wrote L2 for line 2 and L1 for line 1, which means that one line is on top of the other. It is the exact same line. If you simplified the second line, it would end up being the same equation as the first. So that means it's got infinitely many solutions. Finally, in our last graph, we see 2 lines that are parallel. Parallel meaning they will never cross or touch each other. Okay, they're just going to kind of travel side by side like this forever. I know this is true because my slopes are the same. Okay, so that's how I know they're parallel. Again, we talked about that in the graphing video. And so I can say that the system has no solution. Again, systems, their solutions are where the lines cross. So if they never cross, then they'll never have a solution. So the system has no solution. Okay, so continuing on with our mid-unit practice. Now they're giving us a system of equations and they want us to graph it and decide what the solution is. Now remember, it is possible that there's no solution or infinitely many solutions, and they give you those options here as a button. But let's go ahead and graph this first. So if you haven't practiced this already, now is a great time. We have this line tool here, which is nice. And again, if you haven't practiced graphing lines on ALEKS, please make sure you do. Okay, so in the first line, I know that my y-intercept is a +3, it's given. And my slope is -3, which means I'm going to go down 3 and to the right 1. And again, I'm kind of rushing through this so that you guys kind of get an idea about how these problems all work. But if you need more detailed explanations, check out the older videos or come visit me on Zoom. You know, we can work on things together there. I'm going to go ahead and graph my second line, which is y-intercept of -1 and the slope of no number there. But we know from experience that that means a -1 in front of the x, right? So we've got a -1, negative slope. My little person is walking down, right? Walking down, negative slope. And I can see very clearly that they cross at the point 2, -3. Okay, so again, just looking for intersection points. Let's continue on with 4. We're about halfway there, so keep it up. In this one, we're using substitution to solve. Okay, so I'm going to work this out just a little bit. So again, you guys get some support in how these are solved. It's kind of like a review or a recap of everything that's been going on for the past 2 weeks. So I've got this one, which is already isolated, this x, right? It's already isolated, and I know that x is equal to 3y minus 11. So using this equation, let's choose a different color here. I've got 3x plus 2y equals 11. And in substitution method, I am just taking what I have for x and I am plugging it into the equation. Okay, and so what that looks like, it starts to look worse before it looks better. But I've got 3y minus 11 in parentheses. I'm going to need distributive property there. And then I've got plus 2y equals 11. And now I can continue my work. 3 times 3y is 9y. 3 times -11 is -33. I'm going to continue. I'm going to combine like terms here. 11y minus 33 equals 11. We'll add 33 to both sides. 11y equals 44. And divide both sides by 11. Y equals 4. Okay, so I'm almost done, and actually your ALEKS program is really nice in that it asks you for each part. So we found y equals 4. I put it at the bottom. Even though it was first, I didn't put it up here because that's x. So y equals 4, perfect. Now we're still kind of stuck with what's x though, right? And so if we remember from our work with substitution method, now I can go back and use that top pink function, x equals 3y minus 11, to plug in y, which is now 4. Okay, so again, x equals 3 times, and this time we're using 4 for y. I'm just going to simplify. X equals 3 times 4, that's 12. And x equals 12 minus 11, which is 1. So I found both parts. And again, I apologize. I know I'm really racing through this, but it's just supposed to be like a review. So if any of this is feeling very foreign, check out the old videos, okay? So I can take it through step by step and a little slower. All right, let's look at 5. This time 5 is elimination method. So again, quick review. I need these things to be opposite somewhere. I need either the x's to be opposites of each other or the y terms to be opposite of each other. And if you notice, the y terms are pretty close. They're both 5y, which is nice, but they're not opposite yet. So let's make one of them opposite by multiplying the top equation by a -1. That's going to end up making my 5 negative, and then they'll be able to cancel out. Okay, so I've got, once I multiply the -1 through, I've got -4x, and then -1 times +5y is a -5y, and then -1 times 10 is a -10. And then the bottom function I can just rewrite. This one was good to go. So I've got 8x plus 5y equals 30. And when I work through this, I see that my 5y's cancel, right? That becomes 0, 5 minus 5. Over here on the left, and again, notice my x's are lined up, my y's are lined up, and then my constants are lined up all with the equal sign here. -4 plus 8 is a +4x, and -10 plus 30 is 20. And when I divide both sides by 4, x equals 5. Okay, so we've got x equals 5 here. I've got part of my solution, there it is. Now I need y. And again, all I'm going to do is substitute into one of the equations that I liked. So I'm going to go ahead and stick with the pink equation because the numbers are a little smaller, and that's really the only reason. I'm using the original here. Okay, 4x plus 5y equals 10. And I'm going to go ahead and substitute 5 in for x. And I'll simplify. 4 times 5 is 20. Subtract 20 from both sides. 5y equals -10. And y equals -2. Okay, so I've got myself an answer. So let's go ahead and plug it in and see if our answer works. And it does. Alex is so nice. It checks our answers for us and we know right away. Okay, so let's keep going. And just as a reminder, so the rest is going to be about the same, okay? I'm looking for systems by elimination again here. But just as a reminder, in the previous videos I mentioned that you can use any method that you want. So if you become really, really masterful at substitution method, go for it. Use it for all of these. It doesn't really specify which method you have to use. Although for this one, since the x's and the y's and the constants are already lined up, sometimes it's nicer to use elimination method. But at the end of the day, you could isolate a variable, plug it in, do all that kind of stuff. So whatever you feel comfortable with, you do. As long as it's by your own hand and you're doing your own work, I am okay with whatever method you choose to use to solve these problems. Okay, now I did want to look at a problem like number 7. Okay, so let's look at number 7. Some weird things happen with problem number 7. Okay, let's look at system A. And I'm going to go ahead and write system A out, except I'm going to use elimination method, and I need one of these to be opposite, so I'm going to go ahead and multiply it by -1. When I do that, I get -2x minus 5y equals -9. And then the bottom function stays the same. I didn't change that one. And I did it because I wanted to cancel out, but when I do that, look at what happens here. Unfortunately for us, 2x, -2x and 2x, that cancels out, right? It's equal to 0, 2 minus 2. And unfortunately, the same thing happens with the y's. 5 minus 5, that's 0, so it cancels out. So the weird thing that happens here is I end up with 0 equals -5, and that doesn't make sense. Okay, I'm sad. Because 0 equals -5, that's, I mean, where does that even hold true, right? Not on Earth. So if you remember from the beginning of this school year, when we had solutions like this, it was actually no solution. And I spoke about this briefly in our videos, but just as a reminder to all, when I'm trying to solve and something weird like this happens, that means there's no solution. And so I can click that. Okay. Let's check out System B. System B has y equals 6x and y equals x. Okay, so that's about all the support that I'm going to give you for now for the practice mid-unit. Hopefully you stuck with me long enough to get this little outro here for our video. A couple of things. Just a reminder, because I haven't had a lot of people sign in, and I'm not offended. I know you're probably busy trying to catch up with other classes, but I have office hours for my Algebra 1 classes on Thursdays and Fridays. It's posted in your Algebra 1 calendar. So what that means is, if you need to meet with me because you're stuck and you don't have another class that you have to report to for Zoom, feel free to jump into the Zoom link that's associated with that day, again, on our Algebra 1 calendar on Schoology. Okay, remember we have a link there that says Algebra 1 Spring Calendar. Click there, find the date, and then click on the Zoom link so you can meet with me. Okay, usually we meet up, we have a few students. Sometimes we just talk about life and we try to catch up and see how everyone's doing. But occasionally people come with some really good math questions and I can help them. Okay, so it's kind of like when you guys used to stop by at lunchtime to get a little bit of extra help on your homework or your classwork. So again, if you feel like you're struggling with any of this stuff and you have some questions that I was not able to answer in the videos, please feel free to hop into Zoom Thursday or Friday mornings at 10:30. Okay, it's okay if you're not in period 6 and you go on Friday, or if you're not in period 3 and you go on Thursday. It's Algebra 1 material and you guys are all learning the same stuff. So feel free to hop into Zoom and ask questions or just say hello. It would be really nice to see more of you and to be able to support you if you need it. So again, it's not mandatory. I'm not taking off points if you don't show up in Zoom. I'm not allowed to do that, but it is a great opportunity for you to get some help if you need it. Okay, so if there's any other questions or comments or suggestions, please feel free as always to message me. I hope you're all still doing well, and I hope you're staying safe and doing your best to time manage all this online stuff. And you know where to reach me if you need any help. Okay, so take care, and I'll see you guys next time.